Okay, I want to introduce you to confidence intervals. Recall from an earlier lesson on sampling distributions, we wanted to know the proportion of students who had at least one tattoo. So instead of asking everyone, we decided to take a sample. Now with the concept of the sampling distribution, we observe the effect of the sampling distribution of p hat. Remember, if we had 30 different samples, we saw that it was approximately normally distributed. However, in practice, we actually only get one sample, and we have to make a prediction about the population based on this one sample. Suppose that we went out and asked 100 students if they had a tattoo. Suppose that our sample was 24 out of 100, which is 0.24 or 24%. So how confident are we that our sample is close to the true population proportion? It's unlikely that exactly 24% of students at your campus have at least one tattoo. We will often express our estimation as an interval around an estimate. So if we had to choose one number to estimate this population proportion of those who had at least one tattoo, what would you use? You guessed it, 0.24. So, but how confident are we that our sample is close to the true population proportion? It's unlikely that exactly 24% of students at your campus have at least one tattoo. How would our sample proportion p hat vary if we took several different samples with n equal to 100 from this sample population? So again, recall that we looked at this when we investigated the sampling distribution in an earlier module, where the sample proportion was the number of successes in the sample divided by the total in the sample. So p hat equals x over n. So we often express our estimation as an interval around this estimate. This confidence interval, it's expressed as point estimate plus or minus the margin of error. So the question is, what is the margin of error? We have our point estimate, 0.24. So recall that with the sampling distribution of p hat, and we measure the variability with the standard deviation, that was sigma sub p hat equals the square root of pq over n, or the square root of p times 1 minus p over n. Okay, so this should be pretty easy, right? But not so fast. We don't know p, so we must estimate it with, you guessed it, p hat. So this estimate of the standard deviation is called the standard error, sometimes abbreviated SE, of the sample proportion p hat. So this standard error is going to be a part of the margin of error. Okay, so just again a reminder, our estimate we found for the sample proportion was 0.24. And using the standard error formula, we're going to plug in our p hat. We get square root of 0.24 times 0.76 all over 100. Put that into the calculator, you're going to get about 0.043. So we said this standard error is actually just part of the margin of error. So what's the other part? Well, the other part is the number of standard errors. So very similar to when we looked at the normal distribution. So for instance, recall that about 95% of the data fall between two standard deviations of the mean. Our margin of error is 2 times the standard error, which we found earlier to be 0.043. So this is going to be 0.086. So putting this all together, we have point estimate plus or minus margin of error. So it's p hat plus or minus 2 times the standard error of p hat. So 0.24 plus 0.086. We can go and add and subtract this. So 0.24 plus 0.086 is 0.326, and 0.24 minus 0.086, which is 0.154. So what is the interpretation? So recall what we just did. We took a sample, obtained a point estimate of 0.24. So if we had to give, again, just one value that would estimate the proportion or percent of those who had at least one tattoo, we would say 0.24. However, we recognize there's some error here. So if another sample was taken, it would probably be different than 0.24. So we constructed an interval that took into account this margin of error. So in this example, we looked where 95% of the sample proportions would be. That is, for 95% of the random samples, p hat will be no more than 2 standard errors away from p, the true proportion. So we are 95% confident the true proportion of those who have at least one tattoo is between 15.4% and 32.6%. Or another way to say this is we are 95% confident that between 15.4% and 32.6% of students at the school have at least one tattoo. I want to caution you, we have to be really careful when interpreting these intervals. I wouldn't venture out too much on your own in the beginning on this until you really grasp what the confidence interval is. Our confidence is about the interval itself. So the true proportion is either in the interval or it's not. So think of it this way. If we took 100 different samples from this population, about 95 of them would contain the true proportion of those with tattoos. 5 of them would not. So ours may be one of the 95, but it may be one of the 5 duds. We just don't know which. So we are 95% confident that ours does contain the true proportion, but it certainly could be one of the duds that does not.